a bunch of them.
Here we go. We are on lesson 1.8, day 2. So next page. Here we are. And what we did on Wednesday, jump into this lesson, we did talk about this stuff and go over some samples. We did examples 1 through 3. Today, I'm going to do examples 4, 5, and 6, and a couple odd items for you so that you'll have some additional samples. Now remember, I'm going to do my own 4, 5, and 6, so hopefully these will strike you well. The book examples are there for you too. So here's example 4, and this is mine. By the way, this example 4, is a distance is equal to rate times time problem. If distance is equal to rate times time, then any of the things associated with that can be found out if you know 2 of the things. So here we go. By the way, people that hate algebra and word problems always talk about these types of problems. Like helicopter left, nope, that's not the right problem. I'm copying the one out of the book. Hold on. A car leaves town going, and this is the rate, 40 miles per hour. Huh?
We did it again before.
I did the car and I did the sum of 3 consecutive integers. Yikes, I sure did. All right, so then I'm going to do example 6. Dylan, thank you. Wow. I think I got further with you guys than I expected because you guys are superstars. Example 6. Okay. Okay, here we go. This is my sample 6. Patrick's dad is F years old. Patrick's dad is F years old. You guys are going to love this one. Find Patrick's age if this year his age, this is still Patrick's, his age is 3 years more than half his father's age. Anybody's eyeballs bleeding? Patrick's age is F years old. Patrick's dad age is F years old. Dad and Pat. Age. This should say next year, I'm sorry. Next year.
Wait, what is?
Patrick's dad is F years old. Find Patrick's age if next year his, that's Patrick's, age is 3 years more than half his father's age. Well, we know dad is F. We know that much, don't we? Oh my goodness. Okay, so Percy's 99% of the way there. Find Patrick's age if next year his age, no, +1. If next year Patrick's age is 3 years more than half his father's age. Now, this to me is always kind of wacky because I'm thinking, well, next year should be included in this, but it's not. Okay? So some of you might be thinking, well, the next year is included in this. No. Next year, his age is 3 years more than half his father's age. So Patrick's age, and this is a real tough one, Patrick's age is defined as 1/2 f plus 3 plus 1. And there you have it. Okay? One of the more difficult problems, faux show, faux show. All right. That one is sample 6, or at least it relates to sample 6. Let's do written exercises 17 and 19. Because you guys only went up to 15. 17 and 19. So I'm on page 47 and then 48. Here's 17. A quadrilateral has a perimeter of 60. You guys can see it. I'm not writing it out. It's actually right at the bottom of 47. A quadrilateral has a perimeter of 60. And the lengths of its sides are consecutive odd numbers. Okay, so this quadrilateral doesn't really describe it. It's actually more like a trapezoid because it gets, each side is bigger than the previous. So that's still a quadrilateral. But since it's saying that the measurements of the sides are consecutive odds, if I start with n as the first one, how do I get to the next odd number? Plus 2, bravo. Again, referring back to the original. How do I get to the next odd, class? Yep, last one. 2, 4, and 6. And you could test yourself by saying, well, what if this one is 1? If this one is 1, then that means 3. 1 plus 4 is 5. And 1 plus 6 is 7. So by describing it this way, we're correct, if they're consecutive odds. A quadrilateral has a perimeter of 60, and the length of its sides are consecutive odds. So in order to get perimeter, you add the sides, right? N plus 2 plus n plus 4, n plus 6 equals 60. To summarize this mess, I'm going to combine my n's. Looks like 4n plus 12. Now, if you go in the back of the book, you'll see this. As a matter of fact, it will also separate out the sides for you, and it'll look something like this. So if you give me this answer with or without the parentheses, I'm okay with that. If you collect like terms, I'm even more okay with it, because then you're on your way to solving. No, it doesn't say you have to. Isn't it nuts? Yeah. It's like, bring me 3/4 of the way there and drop me off. 19. This is the last one that I'm going to do with you today. So that's 17. Can I flip? Adam purchased a shirt at regular price. Later, he purchased 2 more shirts at $2 off the regular price. He spent a total of $41 for the 3 shirts. So it sounds like he's purchasing shirts at 2 different scenarios. Regular price and sale price. Would you agree? Okay, so that's the description of the shirts. Now, I don't know if you guys remember this, if it was in this lesson or last year or what, but one of the scenarios that you'll oftentimes utilize in many different cases is total dollar amount, whether it's cost, or whether it's like what you get paid per hour working at wherever. Total dollars is equivalent to how many of the items, again, you might work 6 hours or you might buy 6 apples. The total cost is equivalent to how many you buy at the price for each one. Okay? So that being said, let's dissect what they've given us. As far as the count, how many shirts did he buy at regular price? 1. And how many did he buy at cheapo? 2 cheapos. Okay, wonderful. Do we know the cost specifically? No, but we do know he paid full price for that original shirt. And relating to the original shirt, how can I say $2 cheaper for the sale shirt? C minus 2 is right. Bravo. Do I know the total? The total, no yawning. It's contagious. Okay. Looks to me like the equation, the sum of those things, is the regular shirt cost added to the sale shirts cost gives us the total dollars spent, right? Well, to achieve the regular shirt cost, you have to multiply count by dollars. 1 times C is C. Would you agree? All right. The sale, count times dollars. We're going to just leave it count times dollars. If we were solving it, we'd go ahead and distribute it in. But since they're not telling us to solve it, I'm not going to make you. If you do, great. But if you don't, it's okay. And the total dollars is what, 41 bucks? Okay. In the back of your textbook, it will look like this. However, if you do go further and give me this, any of these levels is okay, really. Okay, any of those levels is just fine with me. Just know that if you do this, and the back of the book says this, you're not wrong. Okay, you're not wrong. Okay, they're not saying give a simplified equation to solve it for that. The earlier ones they do, but those last couple they don't. And I'm not going to ding you for that.